And we are live. Welcome back to Math with Doug, Geometry with Doug, Geometry of Composite Shapes with Doug, who is encumbered by a dog who will now sit down on her comfy armchair and relax for the next hour. Down. Stay. Thank you. Okay, so this is a Celtic shirt. Celtic are a soccer team from Glasgow in Scotland. They are the Irish soccer team from Glasgow. Why is there an Irish soccer team in Scotland? I don't know. Well, I do know, but I'm not going to talk about it. What I am going to talk about is the geometry of composite shapes, which is a really fun branch of geometry. So we have done quite a bit so far. And one of the things that we've done is the areas of squares, rectangles, trapezoids, parallelograms, and triangles. So today, we're going to learn the area of some other shapes, but there is a special twist here. This is a composite shape. Look at it. What is it? It's kind of a weird sort of L-shaped thing. We don't have an area formula for that. How are we going to find the area of the shape if we don't have a formula? Look at this thing. It's a little bit more cluttered, but we have this weird thing. How many sides are there? 1, 2, 3, 4, 5, 6-sided figure. Some of the angles go into the center of the figure, other angles sort of don't, and we don't have an area formula for this shape, whatever we want to call it. In fact, I don't know if we even have a name for this shape. I can't think of a good name for it. L shape, okay, sort of a name for that one. So we are going to find the areas of both of these shapes and a few more. So what is a composite shape? That's how we spell it, composite shape. There's no specific area formula, but the shape we're talking about is composed of one or more familiar shapes. Oh, so if, for instance, we were to break this shape down into two rectangles, and I'll show you what rectangles I mean by drawing this little dotted line. Okay, now we have this lower rectangle and this upper one, and we know the area formula for a rectangle. So we can find the area of the two rectangles and add it together. I wouldn't be surprised if all of you are successfully doing that before I even get to that shape, because I'm going to start with this one. What's this one? How are we going to break this down into two familiar shapes? It might be difficult if I didn't have any lines or dotted lines or right angle symbols or dimensions in the center of the shape, but the way I've drawn it, it might jump out at you that what's to the left of this line is an isosceles trapezoid, and we have a formula for that. And what is to the right of that line is a parallelogram, and we have a formula for that. So that's the one we're going to do first. We are going to find the area of this trapezoid and the area of that parallelogram, and we are going to add them together and find the area of this unnamed shape. To do that, I need some space for some calculations. So I'm going to erase this definition of a composite shape, description of a composite shape, or whatever I want to call it. And now we have some space to work with. The area of this shape, let me see how this is showing. Okay, good. The area is going to be equal to the area of the isosceles trapezoid plus the area of the parallelogram. I'm going to say the area of the parallelogram first because that is base times height. So a short, easy to write down area formula plus the area of the isosceles trapezoid, and the area of a trapezoid formula is a little bit longer. 1/2 base 1 plus base 2 times height. So I put that nice and high so we have room for a lot of calculations, which will be equal to base times height for the parallelogram. Now we see a 12-inch side here and a 12-inch side there. The base is 12 inches in this parallelogram. The height might not be quite so easy to see because I kind of made it skinny. So I put this dotted line with the right angle symbol there so you can see that that is a height. And a height, I will remind you, has to be perpendicular to the base. So that little dotted line is my height, and it is perpendicular. And that dotted line is 4 inches long. So, why did I put this dot here? That's supposed to be a multiplication symbol, not a decimal. So it is 12 times 4. It is that simple with this parallelogram. But we also have the isosceles trapezoid. So 1/2 times, what are my bases? It doesn't matter which one we call base 1 and which one we call base 2. A lot of people are in the habit of always calling the larger, the longer base 1. I often am in that habit myself, so I'll do it right now. Base 1 is 18 inches. Base 2 is 12 inches, which is the same base that we use for our parallelogram. And then the height of the trapezoid is this 7 inches. And we can see, yes, that height, I drew it with a dotted line, and it is perpendicular to the base. That's what we want in a height. So we now have everything we need. We can start simplifying. 12 times 4 is equal to 48. 18 plus 12 is 30. And now we have a choice of how we want to multiply this out. There's more than one way of doing it because we're multiplying. So of course, a times b times c is equal to this to a times b times. It doesn't matter which one you multiply first. So I'm going to start by saying half of 30, since 30 is an even number, that's an easy one. Half of 30 is 15. So half of 30 equals 15. I still have to multiply that by the 7. 7 times 15 is 105. And we're done. We've actually managed to complete this already. That wasn't really that difficult, was it? It is just two familiar shapes. And remembering to add the areas of those together again. So 105 plus 48 is going to be 153. All of these dimensions were in inches, so this is therefore square inches. And all the dimensions I'm going to use for the whole lesson are going to be in inches, so that we can focus on what this lesson is about, which is the composite shape. Now I'm going to erase this, and I'm finished. I found the area of this thing, but I am also going to point out to you that often with composite shapes we have choices as to how we break them apart. And I'll illustrate that a little bit more with my next example. But if we really wanted to, we could say this isosceles trapezoid itself is composed of some smaller shapes, like this little right triangle and this other right triangle, which have to be equal in area because of the fact that this is isosceles, and the rectangle in between the two. Now, how would I find the base and height of the two triangles? Well, the height could be the 7 inches. The base would be this little piece here. But if we take the 18-inch length of base 1 and subtract the 12 inches from here, we're left with 6. And then if we take that 6 inches and divide it in half, it means that this little piece is 3 inches, that little piece is 3 inches. We have enough information to do the area of triangle formula if we really wanted to. And then if we're taking that 12 inches away from base 1, if we take the 3 inches and the other 3 inches away from the base 1, then it would be 12 inches. And yes, this little section in the middle that looks like a rectangle would be a rectangle with a base of 12 and a height of 7, or you could say it the other way around if you want, a base of 7 and a height of 12. So you see all the options that are available. Too many options, actually. I don't want to make it too complicated. I like the idea of just breaking it into two familiar shapes instead of a whole bunch, because that little suggestion is one triangle, two triangle, then a rectangle, and a parallelogram. That's 4 shapes. So it makes a bit of a meal of it. It makes it a little bit more challenging than you really have to make it. If the student really wants to do it, I think that that student, if they're careful, would be able to get to the correct answer. They would end up with the same area once they added together all these little shapes. Just to make it even more potentially complicated, even the parallelogram could be divided into 2 little triangles. If I drew another dotted line across here and a little tiny rectangle. Okay, now I'm going crazy. All right, I'm going crazy with all the options for dividing a composite shape into one or more smaller familiar shapes. All the familiar shapes I mentioned: rectangle, rectangle, triangle, 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 triangle. We know the area formulas for those. We can do it. We have the power to do this. But instead of doing that, I'm going to erase it. Erase, erase, erase. Erase, erase, erase. Yeah, Mocha thinks I'm crazy. She said, yes, you are making a meal of it. And by the way, isn't it time for my supper meal soon? And my answer to her is, in about 50 minutes, it will be time for your supper meal. So you're just going to have to be patient, dog. And I'm going to take a sip of my fizzy water. Watermelon. Okay, now we have this shape. And I have all this space to do calculations, and I'm glad because I realized that there is more than one way to break this down into familiar shapes, and I'm going to show more than one way of doing it. There may be, I don't even know how many different ways I could do it. I didn't try to think of every different way that I could break this into familiar shapes. I thought of 3 ways, and that's enough for me for now, and I'm just going to stick with those. The first way we already talked about. By drawing this little dotted line that I drew here, you can see how I broke it into 2 rectangles. And all the information is there to find the area of those 2 rectangles. Let me go way over here. Let's see. So the area of the composite shape will be equal to the area of a rectangle, which is base times height, plus the area of another rectangle, which is also base times height. So you can see this one looks to be simpler. And I think, yes, I consider this to be a little simpler than the previous example. But the rectangles, let's get into those. One of those rectangles has a 5-inch height and a 20-inch base. So that's going to be 20 times 5. And then the other rectangle will have an 8-inch base and a 10-inch height. We have to be careful. It's not going to have a 15-inch height. We've cut off that part and used it already, so this 10 inches becomes useful to me as the height of the rectangle. 8 times 10. 20 times 5 is 100, and 8 times 10 is 80, so we have an area of 180 square inches. Quick and easy to do. Okay, now let me do it again. But instead of drawing the line here, I'm going to draw that line here. And again, we have 2 rectangles. So let's do that one. Where should I do this? I'm trying to remember how to come up with a strategy here. I'll do it here. So it's the same. It's the same formula, which is the composite formula. So it's going to be area equals base times height plus base times height again. That hasn't changed, but the base and the height that we're using have changed. Okay, this one on the right still has a base of 8 inches, but its height is 15. 8 times 15. And then this one over here still has a height of 5 inches, but its base isn't 20 anymore. Its base is now 12. So it's 12 times 5. 8 times 15 is 120. 8 times 10 is 80. 8 times 5 is 40. 80 plus 40. Yes, it is 120. And 12 times 5 is 60. And 120 plus 60, oops, I put a multiplication symbol, tisk, tisk, no. That is a plus, 120 plus 60 is equal to 180 square inches. Same answer. 2 different ways of dividing this into smaller familiar shapes, both of which are rectangles, and we get the right answer either way. That's great. One last way. I really like this one, but it's not mandatory. The student is not required to answer the question 3 times. The student is required to answer the question once. What I'm trying to cover here is the fact that one of the students might have chosen this strategy, another student may have chosen this strategy, and there may be a 3rd student out there who wants more of a challenge and is trying to think of a more creative way to divide this into smaller familiar shapes, who may have come up with this strategy. Oh, with that dotted line, I have divided my composite shape into 2 right trapezoids. So I can use the trapezoid formula twice. I left a lot of space along here because I'll need it because the trapezoid formula is longer. So my area is going to be the area of a trapezoid, which is 1/2 B1 plus B2 times height plus the area of another trapezoid, which is also 1/2 b1 plus b2 times height. Yes, we can do this. We know how to do the area of a trapezoid. We did several of them last week, and we've already done one in the previous example today. I can do this. Okay, now we have to be careful. What are the, I thought I would have to be careful, but I feel like I can really see what I'm doing quite well. For this one here, base one, well, one of the bases is 20 inches and the other base is 12. And the height is 5. For this one over here, one of the bases is 15 inches, the other one is 10 inches, and the height is 8. I can see what I need really easily. So 1/2 20 plus 12 times 5 plus 1/2 15 plus 10 times 8. Okay, let's see what happens when we simplify this. 20 plus 12 is 32. And 15 plus 10 is 25. And again, there's more than one way that I can choose to go through the simplification process, but I like the idea of multiplying the 1/2 by an even number. 1/2 of 32 is 16. So these two combine to give 16. I still have to multiply that by 5. And then 1/2 of 8 is 4. So I'm choosing to use the 8 and not the 25 because the 8 is even and it makes it faster and easier. 1/2 of 8 is 4, and then the 25 still has to be multiplied. I'm running out of space down there, so I'm going to keep going this way. 16 times 5 happens to be 80, and 4 times 25 happens to be 100. So my answer is 180 square inches. Same answer. 3 different strategies, and I suppose there have to be more possible strategies for a student if they really want to. If you want to have one of those open-ended assignments that turns into a big giant project, you might say, well, try and come up with all of the different strategies that could work to find the 180 square inch area of this composite shape. I'm afraid to assign that because I'm worried that the number of different ways of doing it might be just too big. And when you really think about it, yeah, I could break some shapes into a whole lot of smaller rectangles. So there may be an infinite number of correct answers to that problem. I'm not sure. But I'm not assigning that. I think 3 times is enough, and I'm not going to be in the habit of always answering every question 2 times or 3 times. I'll run out of time too quickly if I do that. So far, I'm doing okay for time, and I'm going to stop and stretch just for a second. Noticing there's a little dog over there who I don't want to say by name because I don't want to interrupt her and distract her, who's actually kind of sitting up in the armchair looking at me, but her eyes are closing. Dogs can get comfortable in any position there is. Okay, I'm going to erase and I'm going to make a new composite shape, and we're going to keep on practicing. We want to try composite shapes that can be broken down into familiar shapes, which include all of the shapes that we have been practicing with. We've already used several. We've used an isosceles trapezoid and these 2 right trapezoids, so we're doing great for trapezoids. 1 parallelogram, several rectangles. But there are also triangles and there are squares, and I want to make sure to include those as well. My next one, erase. All of the beautiful work that I'm so proud of gets absorbed into this cloth, and I have to start over and create something else that's just as beautiful. It's a good thing that mathematics has an infinite amount of beautiful situations for us to work on. Okay, I'm going to need a ruler. I'm going to start by drawing a square, and I'm going to draw it over here, not too far over there, and I'm going to make the side length 11 inches. There. A little crooked the line up at the top there. I'll fix that later. 11 inches. 11 inches. Can't even see the 11 because the red handle's in the way. And then 11 inches. Now, if I did a good job of freehanding that, it would mean that this would go, oh, beautiful. Quite pleased with that. Okay, so that's a square. And connected to it, I'm going to put a right trapezoid. Now, what did I choose for the size? I think I'm going to go for 11 inches again. Let's make sure that that fits in the window, and it does. And then this here is going to be 19 inches. 19, all the way down there. And then I'm just going to connect these last two endpoints, vertices. We have a composite shape. There's no area formula for this shape, but we can see that it is composed of a square and a right trapezoid. I will say that that is enough information. I have to label it though. 19 inches, will this fit? Yes, it will. 19 inches. And this square is 11 inches. I will put an 11 here. Move it further. And 11 inches down here. And then, well, if that's, and oh yes, this was 11 inches long. So what I can do is I will label this as 22 inches. And we can see that it's the length of the entire side up there. Now, could I divide it into two or more smaller familiar shapes in more than one way? Yes. And the answer is always going to be yes. But I'm just going to go with the square and the right trapezoid this time. The area of this shape is going to be the area of a square, which is side length squared, plus the area of a trapezoid, which is 1/2 b1 plus b2 times h. The side length of the square is 11. Then the bases of the trapezoid are 19 and 11, which is easy to see, but the height isn't necessarily so easy to see. That's this bit. So I can show my extra step. 22 inches, which is the length of this whole thing, minus 11 inches, which is the length of this part. It has to be equal to this 11-inch side over here because it's a square. 22 minus 11 equals 11, and that 11 is the length of this part, which is the height of my trapezoid. So I'm going to put an 11 here. And now we can find our area. 11 squared happens, well, we have done our multiplication tables up to 12 times 12, right? So 11 squared happens to be 121. And then 1/2, 19 plus 11 is 30. I'm doing that first. And 30 is even, half of 30 is 15, so I have 121 plus 15 times 11. 15 times 11 ventures a little bit outside of the 12 times 12 multiplication tables, but I don't care because I know I can multiply anything really, and I even can go and grab my calculator if I want, but I'm going to try to do it without. 10 times 15 is 150, and 1 times 15 is 15, and 150 plus 15 would be 165. So we have 121 plus 165, and the overall area of our composite shape is 286 square inches. Nothing but fun, nothing but fun. Now we've used rectangles, one square, one parallelogram, lots of trapezoids. So the things that we have neglected are the triangles. Can I make a composite shape out of just triangles? Two triangles, for instance. But two different types of triangles. I think I can. So I'm going to erase the beauty to make room for more beauty. Okay, a triangle. So I'll start by drawing a line, which is, I'll just draw a vertical line, and I'm going to make that 16 inches in length. Then I can do a right triangle with that as one of its bases. So I'm going to draw a perpendicular line, and I'll make that 15 inches. And I'll show my right angle. And I'll label the 15 inches. Not wanting to label the 16 yet because I'm not sure what else I'm going to draw, but I'll finish this right triangle. I'll draw my hypotenuse. There. And I don't know how long that is because it doesn't matter. Because, well, it doesn't matter, but I don't need to know how long it is yet, and I might not need to know how long it is at all because we are finding the area. We're not looking for a perimeter. We're not covering any perimeters today. I am going to draw the equilateral. I'm going to make this left triangle equilateral, and that means I want the two ends of my compass to be 11 inches, not 11, it was 16 inches apart. So I'll use that side to measure the 16 inches, and then I'll draw an arc, and then I'll go to the other point here and I'll draw another arc. Oops, that was a messy. A little better. Okay, so this is the point that where the two arcs cross. That means if I draw from here to that point, and from that point over to here, I should have an equilateral triangle. So that will be 16 inches, this is 16 inches, this is 16 inches, and now I'll measure just to make sure. And yes, lovely 16 inches, lovely 16 inches, and we already knew that was 16 inches. So we have enough information to find the area of this shape. But, ooh, we have some extra work to do. Now, there's more than one way of doing that, because the equilateral triangle can be a little tricky when finding its area. The base is going to be one of these 16-inch sides, but the height is going through the middle of the triangle. So I could do a height, I could draw a height like this, but I want it to go right up through the middle. So I'm finding the middle, and I'm picking a little mark there. And then I'll draw a dotted line that shows the height. And of course, put a little square angle symbol so we can see that it is a height, that it is perpendicular to the base. There are ways of calculating how long that is, but one of the ways that we can do it, since I drew this so neatly, since these are really 16-inch lines, is to simply measure it. So I'm going to measure it. And that is just a little bit more than 13 inches. So I'll do a little arrow pointing in there, and I'll call that 13 inches. I'll just call it 13 inches. Now, if it's not perfect, it's because of drawing error or measurement error. So we don't worry about that. We have enough information so that we can answer the question. We're going to answer the question. The area of a triangle is equal to base times height over 2. But this isn't a triangle. This is a composite shape that's made from at least two triangles. Let's just say an equilateral and a right triangle. So the area is going to be base times height over 2 plus base times height over 2. I have to check my notes to check something. So I'm going to try to quickly do that. If the mouse on my laptop would wake up, I'd be able to do it. There it is. There we go. Aha. I see there was just one little fact that I wanted to find out. And now I see it. I like it. This is interesting. Okay, that gives me ideas for my next couple of examples. We're about halfway through the time that we have. Let's finish this one though. Don't need the ruler right now. Okay, I'll start with the right triangle. And I'll say the base is 16 times the height, which is 15 over 2. But for the equilateral triangle, the base is 16 inches and the height is 13 inches. How to do this? We have choices. 16 times 15, I could find that and then divide it in 2. But maybe it's easier for me if I say, wait, 16 divided by 2 is 8. I'm doing some canceling, really. So if I cancel a 2 here, that turns into a 1, and the 16 turns into an 8. And 8 times 15 I can do a little bit more easily. 8 times 10 is 80, and 8 times 5 is 40. 80 plus 40 is 120. Over here, oh, same thing. I can cancel a 2, leaving a 1 and an 8 up here, and 8 times 13, 8 times 10 is 80, 8 times 3 is 24, 80 plus 24 is 104. We can do this. 120 plus 104 is 224 square inches. So I've covered 2 different types of triangle, 2 different types of trapezoid, a parallelogram, a square, and several rectangles. I've covered everything, haven't I? Maybe I should just say class dismissed early and we'll have a lesson that's only half as long as usual. Or I can challenge myself to think, is this the only way that shapes can be composite? No, it's not. There's another way. Notice how all of the composite shape area formulas that I've managed to put together, the composite formulas that I've managed to put together, involve adding. But that's not the only way for composite formulas to be constructed. We can also have composite formulas that are made with subtraction. So that's what I'm going to do next. Let's stick with some nice simple shapes for our first example. And I think a rectangle is a good way to start. I'm going to go way over here, and I'm going to draw a big rectangle. It's going to have a height of 20 inches and a base of 24. So I'm trying to freehand my right angle here, which I've been doing a lot the past couple of weeks, and I'm getting pretty good at it. 24. Now let me double check my angles and make sure they're close enough to being perfect right angles to satisfy me. And if you can satisfy a math teacher with a right angle, then you're probably okay. That one is yeah, they're very nice. Okay, that means if I were to draw this and measure it at the same time, I should get 20 inches, because this one was 20 inches, it's a rectangle. The opposite sides have to be equal. And oh boy, is that ever a beautiful 20 inches. Yep. We have a rectangle. I'll mark the corners, which is something I occasionally forget to do, but I actually really like doing it. It just makes for a nice, neat drawing. And drawings are meant to be seen. And the person who sees it, you want them to understand what they're seeing. So a drawing where you take advantage of symbols like this to make it more clear what it is you drew is better. But some people might look at this and think it's a square, because the length and the width of the base and the height of this rectangle, not really that different from each other. So if you're wondering whether you have stretchy video, we need to give some more information. So I'm going to give some more information. This is 24 inches and this is 20 inches. Now we have enough information. Now this is very clear, but I'm going to draw something inside it. I want to draw something inside it. And I'm going to go to one of my old standbys, which is this block of wood that I still haven't built anything with. And I'm going to put a square inside it. Now, I could put this square twirled around any way I want, but I think I'll try to sort of center it. I'm going to see how well I can center a square inside a rectangle freehand. Not that it has to be centered. Okay, so this is an interesting shape now. I'm still not being completely clear as to what area I'm asking us to find. And the way to be more clear is for me to shade all of the big rectangle except where the square is. There. Let's find the area of the shaded region. So the area of the shaded region is weird. It's this weird, I don't know what you would call that. This sort of rectangular thing with a square hole in the middle. Could be some giant donut. But we don't care whether it's a donut. What we care about is whether we can find its area and how we would do that. And we will do that by realizing this is also a composite shape. But it's one where you have to subtract instead of adding. I want to find the area of the rectangle, but then I want to subtract the area of the square. And then I'll have the area of the shaded region. So, area of the rectangle, that is base times height. But I am subtracting the area of the square, which is s squared. One thing is missing, which is the side length. I'm afraid of coming up with a different side length for this square because the students who are watching this have probably seen me use this piece of wood before. So they probably already remember that the side length of that square is 6.5 inches. There, enough information. It is a square, its side length is 6.5. Let's find the area of the composite shape, which is base times height, that's 24 times 20, minus side length squared, which is 6.5 squared. It's always 6.5 because Doug keeps on tracing the same thing to make his squares. Okay. No, we had a square earlier today that had 11 inches for a side length, so it's not always 6.5 inches. Okay, 24 times 20. Well, 24 times 10 is 240. 20 is twice as big as 10. So 240 plus 240 is 480. Yes. And now, can I do 6.5 squared in my head? Of course I can, because it is a two-digit number that ends in 5. 6 times 7 equals 42. So this is going to be 42.25. Okay, that's just a trick. But of course, if I used the calculator and did 6.5 times 6.5, it would give me 42.25. And I'm going to prove it because Doug has learned his lesson. 6.5 times 6.5 equals, yes, 42.25. Or I could say 6.5 x squared equals 42.25. We're nearly there. I have to subtract. Can I subtract this from that in my head? Yes. 480 minus 440, 480 minus 40 would be 440, but I have to take away another 2. 440 minus 2 is 438, but I have to take away another 0.25. So there's 437.75. Square inches. A composite shape where we are subtracting the square from the rectangle in order to get the area of the composite shape. It's not always adding, but I really need to use the shading so that people have an idea of what shape it is they're trying to find the area of. And if you thought I was going to erase this without double checking first, Doug has learned his lesson. 480 minus 42.25. 437.75. Okay. How am I doing for time? Not bad, not bad. We have time for at least a couple more composite shapes that involve subtraction. So the first half of the lesson I did a bunch of addition ones. Now I'm doing subtraction ones the rest of the way. And I hope the students agree with me that this is fun, because I find this fun. It doesn't feel like work to me. It just feels like fun. Drawing the shapes is fun. Finding the areas is fun. Figuring out how to break the composite into familiar, smaller shapes is fun. Figuring out more than one correct answer to the same question is fun. Okay. What will be my next shape? We used a rectangle and a square, so let's try something else. How about... I'm using my imagination here. I'm going to start with a right triangle, and I will use an 18-inch side, and no, I'm making it bigger. I'm going to make it 22 inches. Just because I want to have room to fit a smaller shape inside it that I have to remove. Now, forming a right angle, that was 22 inches. This one, I'm going to make this one 19 inches. Okay, right angle, double check. Make sure, yes, that's quite good. Okay, and before I can forget everything, I'm already starting to forget. So, this was 22, yes, 22 inches. I'll write that down. And this was 19, was it? Yes, it is. 19 inches, right that way up here. I'm going to, oh, I need my yardstick because this hypotenuse is so long. Ugh. But what can I do now? I think just another right triangle would be fun. So what I'm going to do, trying to be creative like I said, is I'm going to draw a height from this base, so I need a right angle symbol. No, I'm going to do the symbol on the other side like that. And I'll erase that bit later. And I'm just going to do another right triangle. I'm going to end up using some measuring to figure out the dimensions I have here. So how long is this? That I'll measure, and yes, that's 6 inches. And then how long is this? That is 9 inches. So what I'm going to do is to be creative, 9 inches. I'm going to show it like that because it could get pretty complicated otherwise. And with a bit of erasing, I'm going to show a kind of an interesting looking composite shape. Because I'm not only going to erase that little square angle symbol, I'm going to erase this. And that means I don't need shading. What is the area of this shape? This weird right triangle with a bite taken out of it type of shape. No name for that. No formula for that. But it is a big triangle from which I am cutting out a smaller triangle. So it's going to be the area of a triangle minus the area of another triangle. Let's get the formula ready. Area equals base times height over 2, that is our triangle, but we are going to subtract base times height over 2. Equals, this one, I'm going to say the base is 22, the height is 19. 22 times 19 over 2 minus this one. I'll call the base the 6 and the height the 9, but I could do it the other way around. It's a right triangle, so these two sides that form the right angle are the base and the height. One of them is called the height because it's at a right angle to the base. That is the definition of a height. So 6 times 9 over 2. Trying to make this easier. 22 divided by 2 cancels to give an 11. So that's a 1, that's an 11. And it's just 11 times 19. 10 times 19 is 190. 1 times 19 is 19. 190 plus 19 is 209. 209 square inches. Minus, canceling the 2 here, I have a 3. 3 times 9 is 27. Not so bad. 209 minus 27. 209 minus 7 is 202, and 202 minus 20 would be 182. 182 square inches. Messy, but it's okay. And yes, I've learned my lesson. I'm going to double check it. And I'm going to check the time as well. This one's actually gone really quickly. So, I'm going to do the whole thing. 22 times 19 divided by 2 plus 6 times 9 divided by 2 equals. I said plus. It's not a plus. It's a minus. It's the whole point. Starting over, 22 times 19 divided by 2 minus 6 times 9 divided by 2 equals 182. We got it. Okay. For that, I deserve a reward. Another composite shape where I subtract. That's a bit of a weird one, I admit it. I was being creative. I will try one thing just to be fun. I don't want to get too complicated. So I'm going to try a composite shape where you have to subtract 2 things from the big thing. Well, I may as well start drawing it, and then people can see what it is I'm talking about. The composite shapes could get very complicated, really as complicated as you want them to be. We just don't want to overdo it. So I'll start with a rectangle again. I just want to do something to shake it up, something a little different. So I'm going to make a rectangle that's only 14 inches, but I'll make the length of it long. I'll get my yardstick and try and make a nice right angle. 30. A nice round number. Do it over here as well. Wait, I started at 1, so that's not 30. I need to go 1 inch further. 30. So that's now 30. Okay, I'm just trying to take advantage of the edge of the yardstick to help me get my right angle to turn out good. There. And if I did a good job, this was, I can't remember how long this was to start with. 14. Okay, so this should be 14. Yes, it is. That's good. Okay, we have a rectangle. We have started. Double checking 90 degrees. Yes, 90 degrees. Let's see here. Yes, 90 degrees. Yes, 90 degrees. Yes. So we have a rectangle, and it is 30 by, already forgetting again, 14? 30 inches. By 14 inches. And inside it, I'm going to draw two shapes. But again, I want them to be kind of simple. I don't want it to be too crazy. So I'll do one parallelogram, because we've only done one parallelogram so far. Let's see here. That's 9 inches. Label it on the inside. And then I'm sort of randomly choosing an angle, but that's okay so long as I'm careful to make sure that the two opposite sides are parallel, and therefore this is supposed to be 9 inches. I'm going to have to make it shorter. That's 8 inches because I don't want to go over the edge here, so I'm making this one 1 inch shorter. 8 inches, yes. So when I connect these, I should have a nice parallelogram. Yes, I need to know the height of that parallelogram, but you know what? I'll measure it later to get the height. So we have a parallelogram that we have to subtract from, well, I haven't done the shading yet. I need to do something else. I'm going to put in a square, and I'm not using that thing. I'm not tracing that thing again. I want to make a square. I'll make it smaller. I'll make a square that is 5 inches side length. Tiny little square. Five-inch side length, 5-inch side length. You can see that's a square. It's kind of small. And then this thing I have to measure. What's the height of this parallelogram? It is 4 inches. I'll draw the height with a dotted line the way I like to do. And I'll show that there's a right angle there. And then I have to do it like this. It's getting messy. 4 inches. Can we even see this on the video? Yeah, I suppose so. I guess I should have made the whole drawing much bigger. But we are now ready to show our shading because it is still not clear what the student is being asked to find the area of. It won't be clear until I shade everywhere except inside the square and inside the parallelogram. And then my question says, and I won't write it down, but if I were to write it down, it would say, find the area of the shaded region. It is a composite shape. It's composed of at least three familiar smaller shapes. So we are going to, be careful about the word smaller. They're not smaller than the rectangle, but these two are smaller than the rectangle. Okay, so I'm stumbling over my words. The area is going to be equal to the area of a rectangle, which is base times height, minus the area of a parallelogram, which is also base times height. minus, do I have room? Yes. The area of a square, which is s squared, side length squared. I can do this. Rectangle, 30 times 14. Minus parallelogram, 9 times 4. Minus square, which is 5 squared. 30 times 14. 10 times 14 is 140. So 3 times that would be 420. Minus 9 times 4 is 36. Minus 5 squared is 25. Not so bad. Okay, asking for trouble. 420 minus 25 is 395. Minus 36 is 359. 359 square inches. And then because Doug has learned his lesson, I'm not just doing this, I'm going right to the beginning. 30 times 14 equals, yes, it's 420. 9 times 4 is 36. I have confidence in that one. 5 squared is 25. I have confidence in that one. So 420 minus 36 minus 25, 359. Woo. Okay, I did it. That was fun. So a composite figure can involve subtraction, and you can have more than one smaller familiar shape inside the big shaded one. It can be that way. And I could go a little crazy and draw a big shaded figure with 27 different triangles inside it or something like that. But we don't want this sort of question that takes us a whole week to answer. So we're happy enough with this. What other type? Yes, now there's an example I want to do. I only have a few minutes left, so this is good. There's a type of example I want to do that I haven't done yet. That involves still composite and still involves a subtraction. A little different. Not harder. Just different. Okay. What if I have, this is actually going to seem very similar to the very first one I did, but I'll make sure to use some different numbers. So it's a new question. So I'm going to put 13 inches. So I'll mark that before I can forget. And then over here, I'll do 17 inches. And then here, I'm going to put in a piece of about, I'll put 6 inches. And I want to point out that these are right angles. That's 6 inches. And then up from that, I am going to go 8 inches. And then over here, I'm just going to continue it on until I get to there. And how long is this going to be? Well, we could figure it out, couldn't we? Okay, I think we have enough information here. Let's find the area of this composite shape. Again, there's no area formula for this L shape, but we can break it down into two smaller shapes. That's one of the ways of doing this problem. It's very similar. It's very repetitive of our very first example. Let me do that over here. If I decide to draw a dotted line here, which I can erase later, because it's not the only way I'm doing this problem, then I have two rectangles, and I can say the area is equal to base times height plus base times height, which is going to be 6 times, I have to show an extra step. Where? 13, this, minus 8, which is this, means that's 5. Is that helping me? That's not what I need. I'm doing 6 times 8. Yeah, this is what I'm finding is this. 13 minus 8 equals 5, which tells me, even though my original diagram didn't show that this is 5 inches. I have to keep on stepping off camera, but so long as the calculation is making on camera. Okay, so base times height of this little one is going to be 6 times 8, plus space times height of this one is going to be 17 times 5. It's working. And as we know, there was more than one way of doing that. 6 times 8 is 48. 17 times 5, 5 times 10 is 50, 5 times 7 is 35, so 50 plus 35 is 85. So we end up with an answer, 133 square inches. Did it. Okay, that's one of the ways of doing it. Now I'm going to erase some of the extra stuff that I put in. And including that dotted line, so I threw away my eraser cloth too quickly. What if instead of cutting it into two smaller shapes, which is easy and fun, and we know we can all do it, what if instead I did this? I'm turning it into a big rectangle, if we use all this, that has a 17-inch base and a 13-inch height. Area of a rectangle is base times height, but then I have to subtract this rectangle. We know that's 8. What's this? I have an extra step to do. I'll do it here. 17, that's the whole length here, minus this 6 equals 11. That means this part here is 11. And now we have another rectangle, and I am subtracting. Okay, slow down, say it more clearly, Doug. Big rectangle is 17-inch base times 13-inch height. Minus this little rectangle that I added to the figure, but I'm still going to subtract. 8 times 11 or 11 times 8. Doesn't matter which one we put first. 17 times 13. Okay, I've learned my lesson. I'm going to do this one in the calculator. I'm starting to get tired too. 17 times 13 equals 221. Minus 11 times 8, that's an easy one, that's 88. 221 minus 88. Minus 88. 133 square inches. Okay, this is cool. So we could take this L-shaped thing, no formula for that, break it into two rectangles so that we add them to get the composite area, which is 133 inches, but we can take the same situation and we can expand it into two rectangles so that we subtract instead. That's interesting. That shows a tremendous amount of flexibility that we as mathematicians have when it comes to dealing with composite shapes. We're able to take the same problem and do a composite that involves subtraction and get the right answer, or do a composite that involves addition and get the right answer. That's power. That is having a lot of tools in your geometry toolbox that will allow you to approach any situation with confidence and be able to find an answer. And we are getting pretty close to the end, so I guess it's time for me and the dog to say goodbye. Oh, she's really asleep now. I could see the eyebrows. The whole dog looked like she was asleep, completely slumped in a weird position, but the eyebrows were moving. Dogs and their eyebrows, very expressive. Two things about dogs: very expressive eyebrows, all of them, and able to get comfortable in the most bizarre sprawled out positions that you could. That just makes me jealous. I want to be that comfortable. Okay, thank you very much for being here. It was fun doing composite shapes with you. I look forward to next time where we'll do some even more fun math, because it just keeps on being fun. I guess I should just predict that. And with that, I will say goodbye until next time.